So yesterday we were talking about the different ways of naming polynomials, right? So they're based off of two items. There's the degree of the polynomial and then the name based off of the number of terms, right? So what I want to do is kind of go back through these real quick. Okay, so for the first one, what's the biggest degree? Or what's the degree of the polynomial? As in, what is the biggest power? 4. So what do we call a polynomial degree 4? Quartic. And how many terms do we have? 3, so that would make it a quartic trinomial, right? The second one, what's the biggest power? 2, so it's a quadratic. And how many terms? Just one term, so it's a monomial. And then remember, for these, for the setup here, when we run out of names, right? So anything that's a power of 6 or bigger, we have to actually flip the order. So we go based off of the number of terms, and then we say of degree whatever. So how many terms do I have here? 2. So it's a binomial of degree what? 6, because the degree is 6. Okay, and that's just for the English, because it doesn't make sense to say a polynomial of degree 6, that's a monomial. You can say it that way, but it's a lot more words compared to a binomial of degree 6. Okay? Everybody all right with that? Yes, no, maybe? Yes. All right. So that was yesterday. We also talked about odds and evens, right? Did we get through all this? We just did the odd? Okay. So real quick, for an odd, right? Anybody know what type of graph do we call an odd function? Like, we use 2 words for types, or actually they're letters. For an odd, what do you notice the shape of the graph? It's up in the first and down in the third, so it looks like this, right? So what letter looks similar if you tip it over? S, right, where the ends point in opposite directions. So odd functions are called S-type graphs, and we only call them that because if you look at the ends of the S, are they pointing in the same direction or different directions? Different, right? One's going to the left, one's going to the right. Just like whenever we graph an odd function, the ends have to be pointing in opposite directions, one up and one down. Okay? Everybody all right with that? Yes, no, maybe for odd? Yes. Okay, so this is also an S-type. The type name stays regardless of whether it's a positive A or a negative A. Okay, so any odd function is considered an S-type graph. So part of what you're going to be doing when it comes to the ACTs, they're going to say, which of the following graphs matches this polynomial? And they'll give you a statement, right? So you look at it. What's the biggest power? Okay, if the power is odd, then you know it has to make an S. So you look at the ends. Are they pointing in the same direction or different directions, right? So if it's even, the ends have to match. Everybody okay with that? The other thing that you'll look for is the A. So for an odd, if A is positive, then it's in the first and third. If A is negative, it's in the second and fourth. For an even function, if A is positive, then both ends point up. If A is a negative, then both ends point down. So what you're going to be doing is how they test you on this is they give you the equation, and then your A, B, C, D are 4 different graphs. And you have to pick the graph that matches the equation. So if you know what the general shape of the graph is, just based off of the equation within a few seconds, you can kind of start to pick and choose which ones should stay and which ones you can throw out. Because you can usually throw out 1 or 2 of them that way, and then even if you do have to guess, you're up on your chances of success from 25% to 33% or 50%. Everybody all right with that? Yeah? All right. So everybody okay with the S-type? Okay, so what do we call evens? Anybody know?
What is the S?
It's just S because the shape. So the ends point in opposite directions. So for odd functions, their ends will point in opposite directions. So for even, right, yeah, so, but we don't have a letter that moves that way. So it's like an S and then you tip it over. So what about for the even? Not U, bigger. A double U, right? So this is a W type. And the important thing here, again, is look at the ends, right? So if you look at the W, do the ends point in the same direction or different directions? Same, which both ends point up, both ends point down. So that's what we use the W to signify. A graph type you want me to make. These are just going to be general, okay? So it's just general shapes. So, like, do you want me to do an odd function or an even function? Odd, okay. Do you want me to do a linear, a cubic, or a quintic? Quintic, okay. Is A positive or negative? Positive. So if A is positive for an odd, that means that I have to point up into the first quadrant and down into the third quadrant. So remember, for odd functions, a regular odd function will be in the odd quadrants, 1 and 3. Everybody okay with that? So I'm talking ends, end behavior, 1 and 3. Now, if it's a quintic, how many times am I going to cross the x-axis? 5. That's why it's called a quintic. It has 5 roots. So what that means is it's going to have 5 different sections that are increasing or decreasing. So I've got 1, 2, 3, 4, 5. And if you notice, I've got 1, 2, 3, 4, 5 turns, or 5 sections that are pointing in increasing or decreasing. Is everybody okay with that? So there's a couple of different ways of determining degree. You can look at the number of turns, which is the best way, or, well, actually that's what you want to look at, sorry. I was thinking the number of times it crosses the x-axis, but if it's a 5th power, it can cross the x-axis 5 times, 3 times, or 1 time. And what I mean by that is, let's say it looks like this. I still have 5 sections, right? But how many times am I crossing the x-axis? 3 times. I've got 1, 2, 3. So is this a cubic or a quintic? It's still a quintic because it's got 1, 2, 3, 4, 5 sections in it. Does that make sense or no? So increasing or decreasing pieces is what determines the degree. No, because if you think about a quadratic, did we ever have quadratics graph that never cross the x-axis? They have no solutions, but we can still graph them, right? Any even function can do that. So like for odd functions, a 5th power can cross 5 times, 3 times, or 1 time. Okay? A 9th power, so a function of degree 9 can cross 9 times, 7 times, 5 times, 3 times, or 1 time. Everybody okay with that for odds? For evens, like a 4th degree can cross the axis 4 times, 2 times, or 1 time, or no times. So like a 12th degree can cross the x-axis 12 times, 10 times, 8 times, 6 times, 4 times, 2 times, 1 time, or no times. So that's the general rule. So the number of roots does not necessarily reflect the degree, but the number of sections that are either increasing or decreasing is what does. So for us, we have 1 piece here, right? We have a decreasing section here, that's 2. We have an increasing section here, a decrease here, and then an increase here. So it's a 1, 2, 3, 4, 5th degree. Is everybody okay with that? Yes, no, maybe so? Anybody want to see an even function, or are you guys good? So for an even function, do you want A to be positive or negative? Positive? Okay, and how many roots? Is that what you said? No. Oh, okay. No, I'm not. I'm partially deaf right now, remember? Okay, so you want a negative A? What power do you want me to use? 2, 4, 6? 2? Okay. So we're going to have, which way is this graph going to be pointing? Let me start there. Is it going to point up or point down? Down, because A is negative, right? So that means that the ends are going to be in the 3rd quadrant and the 4th quadrant. So if the power is 2, how many increasing or decreasing sections should I have? 2. So I'll have 1 increasing section and 1 decreasing section. Yeah, so I'm going to have 1 turn, is that what you're talking about? Yeah, okay. So you go up and you start decreasing. So I have 1 increasing, 1 decreasing, power of 2. Everybody okay? So if you think about it, if that's how we deal with, what's a 1st degree polynomial called? How many curves does a line have? None. Which makes sense because if it's a 1st degree, it has to have either 1 increasing section or 1 decreasing section, but it can only have 1 segment. Is everybody okay with that? Yes, no? Okay, so 2nd degree means that there's 2 segments. 3rd degree, there's 3 sections. Everybody good? Yeah, the important thing is the ends. We don't focus a lot in this class on all of the in-betweens. We focus on the end behavior. So if it's a fifth degree polynomial, is A positive or negative? In our hypothetical situation, what do you want it to be? Positive? Okay, so if it's an odd function with a positive A, where do the ends point? Up where? Up in the first, and then down in the third. When A is positive, for an odd, we're in the odd quadrants. So for an odd function, we have to have one pointing up, one pointing down. Okay? And then I'm not going to worry too much about in between. It doesn't matter, but we tend to because the way that we teach math is based off of the English language, so our math statements move left to right. So it's a habit that I picked up because when you're doing domain and range, we always move left to right. So it's one of those things that we usually move left to right across the graph. But it doesn't matter just as long as you pick one and stick with it. But it's either left to right or right to left. You cannot move up and down because your graph should never be moving that way. It'll snake along the x-axis, not the y-axis. Everybody good with the differences between odd and even functions? Yes, no, maybe? So up first is direct substitution. Now, direct substitution is what you've been doing since you were knee-high. Okay? So we're going all the way back to like 4th grade. What does the word substitution mean? Okay, yeah, replace it, right? So what am I replacing here? X, and what am I replacing it with? 3. Okay, so that's the substitution part. What does the word direct mean? What does it mean to be direct? Kind of. Like direct just means you do it, right? You just go and get her done. So what that means is I'm going to actually just replace the X with the what? With the 3. So everywhere I see X, I replace it with a 3. That's what I mean by direct. It's direct substitution, as in I am directly replacing the X's with 3's. Everybody good? All right, so now we evaluate. Order of operations, what do I do first? Parentheses. Is there anything I can do to make those parentheses smaller? No, so what's after parenthesis? Exponent. So what's 3 to the 4th? 81, right? 3 to the 4th is 3 times 3 times 3 times 3, right? What's 3 times 3? 9. So 3 times 3 times 3 times 3 becomes 9 times 9, which is 81. What's 3 to the 3rd? So what's 3 times 3? Times 3 is 27. 4 times 3 is 12. Okay. So I still have multiplication to deal with here. What's 2 times 81? 162. 5 times 27. 5 times 5 is 35. 5 times 2 is 10, so it's 135. And what's negative 12 plus 8 real quick? Negative 4. Okay. So now 162 minus 135 is 27. Minus 4. And what's 27 minus 4? 23. So this is the way that we've done things for a really long time, right? When I give you these problems, you type it in, or you do the math using your order of operations. Everybody good? Yeah. Okay, so this is direct substitution. You know it. You might not love it, but you've been using it for a long time, so you're comfortable with it, right? All right. So this is exactly the same problem as what we just did, but we're going to do it in a different way using something called synthetic substitution. What does the term synthetic mean? Fake? Kind of, right? Well, I mean, like, if you look at synthetic oil, it's still oil, right? But it's been manipulated through a different process, so you get the same result. So you take a different process to get to the same spot. Everybody okay with that, right? That's usually what synthetic means. So, like, if you were thinking synthetic lettuce, we don't mean wax lettuce. We don't mean plastic lettuce. If it's synthetic and truly synthetic, it has to provide you the same nutritional supplement as lettuce. Everybody okay with that, yeah? So, for synthetic substitution, there's a few rules. Okay? Like, synthetic anything is very particular, right? If you look at oil, anybody can like, hey, look, there's oil. We can pull this out of the ground, put a derrick. That's crude oil, right? But does that mean that you can just throw that in your car and have it run right? No. So The process of doing anything synthetic is always particular, so make sure that you're paying attention to this. Because it doesn't matter whether it's synthetic substitution today or synthetic division later on in the chapter, a few rules have to be in place. So first thing is that every power has to be represented when we write out our statement. So what is my degree right now? 4. So that means that I need to have an x to the 4th term. I need to have an x to the 3rd term. I have to have an x squared term. I have to have an x term. And I have to have a constant. Okay? Every term between constant and my degree has to be present. So, do I have an x to the 4th term? Okay, do I have an x to the 3rd? Do I have an x squared? No, that's a problem, right? Do I have an x? And do I have a constant? Okay, so the only piece I'm missing is the x squared. So, who knows? What can I add in to create it? So, I can put in a 0x squared. Why can I just add a 0x squared? Right, because 0 times anything is 0, and does addition by 0 change anything? No. So I'm being sneaky on how I write 0. Okay, but I have to have that placeholder for the synthetic process to work. Okay, the other rule is that you have to list your polynomial in standard form from the biggest power to the smallest power. So again, moving left to right, because we're English-based, biggest power is 4, so I have 4th degree, 3rd degree, 2nd degree, 1st degree, constant. Oh, no. This is just a setup for synthetic. We haven't even started the synthetic process yet. So, everybody okay? So those two things have to happen before you even start synthetic division or synthetic substitution. Your polynomial has to be in standard form, which means biggest power on the left, smallest power being the constant on the right, and you have to have every power present. So you go from your degree all the way down to the constant. You have to have every possible term. Everybody good?
Yes.
Okay. So now we can start synthetic. How the synthetic process works is we're going to start off with a box outside. Box outside. And then you're going to have 2 rows of numbers here with an equal bar. So please set that up. So put your little box outside. 2 lines of room, right? You need 2 lines to write. And then put in your equal bar. And then you'll need a line under the equal bar. So like on your paper, you should have line 1, right? Line 2, and then you'll have another line here. So you should have 3 lines set up like this. On synthetic substitution or synthetic division, the number we're plugging in for x is the number that goes in the box. So what am I putting in x's place? 3, so that goes in the box outside. As far as the top row goes, the top row is just the coefficients from the polynomial. So what's my a right now? What's my a value in this polynomial? 2, so that goes first. What's my b? -5. You must include the sign. Okay, what's my c? d? And my e. Everybody okay so far, yes or no? Okay, so for synthetic, the very first step is we drop the a. So what's my a? 2, this drops and goes down there, okay? And now what we do is we take the number from the equal bar, multiply it with the box outside, and that number goes row 2. So what's 2 times 3? 6, so that goes here. You take the number from the equal bar, multiply it with the box outside, and that number goes into row 2. Okay, like I said, it's synthetic. It's very different than what you're used to doing because it's a synthetic approach, so it's a different approach that gets us to the same spot. Okay? So, everybody okay with dropping 2? 2 times 3 is 6, right? Okay, and then you add these. So what's -5 plus 6? Okay, now I have a new answer in my equal bar, so what do I do with it? Times it by the box outside, so it's 1 times 3. Okay, the product goes in row 2. What do I do with those 2 numbers? So what's 0 plus 3? Okay, number in the equal bar. What do I do with it? Times it by the number outside. What's 3 times 3? What do I do with these 2? What do I get? 5. 5 times 3 is... What do I do with these? What do I get? Huh. Does that number look familiar to anybody? What did we get over here with direct substitution? F of 3 is equal to what? 23. When you use synthetic substitution, the very last number that you add with is the value if you substitute in that x. It's less labor intensive, but because it's a synthetic process, it's a lot more particular, okay? When it comes to substitution, when you use direct substitution, it doesn't matter your order. It doesn't matter whether every power's there. It doesn't matter if it's in standard form. You just take x, replace it with a number, type it in, hit the equal sign, right? So some people like that because it's very robust. With synthetic substitution, it's very particular. It has to be in standard form. Every power has to be present, but the actual synthetic process is quick and easy. Okay, so where most people make their mistakes is actually in the setup, not in the execution. Okay, so do you want to do one more as synthetic substitution real quick? So what's the degree here? 3, right? So that means that I have to have an x cubed term, I have to have an x squared term, I have to have an x term, and I have to have a constant. So take a look up there. Do I have an x cubed? Okay, that's a check. Do I have an x squared? Okay, do I have an x? Do I have a constant? Okay, do I have to add anything then? No, because the biggest power is a 3. So I don't have to go bigger. I just have to make sure that everything's smaller than my degree is there. So over here, the only reason why we did fourth is because it was a 4th degree. Okay, so I never go bigger than my degree. I just have to make sure everything less than it is there. Does that make sense? Okay. So is that in standard form as well? Yeah, so it's in standard form and everything's there. So do I really have to do any work here to set up? No. So I'm going to put my box outside, put my equal bar. What goes in the top row? The what's? Coefficients. So just the coefficients. So once you have your polynomial in standard form and every power there, you just pull the coefficients. Okay, so what's my A? Okay, B, C, D. Okay, and this is going to be my answer, whatever I get in there, right? Okay, so what number goes in the box outside? All right. Any major questions so far? Okay, so first step, what do you do? Drop the 5. What do I do with the number from the bottom? Times it by what's in the box, so what's 5 times 3? Okay, and what do I do with these two numbers? Add them, so what's 15 minus 2? Okay, 13 times 3. 39, 39 minus 8. 31, 31 times 3. 93 plus 16. 109. Okay, so you can feel free to flip that negative into plus and negative, right? So 39 minus 8 is 31, right? Okay, and if you were to plug this in to your calculators using direct substitution, you will get 109. And that's it, we're done. So any major questions on synthetic substitution now? Okay. So before we get into your homework, I want to do a problem from 3 through 8. So please pick one, and it's on page 340, I think, or 341. So somebody with a book, please turn to 5.2, and then somebody pick a problem between 3 and 8. Okay. So the one thing that I haven't talked about yet is how do we actually determine if a function is in fact a polynomial function? So as far as this goes, there's a few things that we have to keep in mind. So it's all about powers when it comes to polynomials, which is why they're in this section. So the main thing is that powers must be positive. Powers cannot have a variable, not an, a variable. And powers must be rational. Okay, so a rational number is something that can be written as a fraction. All right, so mainly we tend to focus on whole numbers here. Everybody okay with that? Yes, no? No. So we're going to need this because the very first question out of the 5 pieces of information that I need for every one of these problems is for you to identify if the equation is a polynomial function or just a function. Okay? So for number 6, can I get the equation, please? All right, so is this a polynomial? Powers must be what? Do I have a negative power? Yep, so this is a no, and you're done. So there's number 6 done. So how about we do number 3? Because if it's a yes, we have to answer everything. And I want to do one of those. So can I get the equation for number 3 really quick, please? 8 minus x squared. Okay, so is this a polynomial? Yeah, I have a positive power, so it's just about powers, right? Positive powers. I don't have a variable as a power, right? I don't have 2x as my exponent, and the powers are rational. So it's a yes. So, yeah. So we're going to do that by putting it in standard form, right? So what's standard form of this equation going to be? Negative x squared plus 8. So you always put your biggest power on the left, right? So what's the lead coefficient? Negative 1, what's the degree? What's the biggest power? 2, so is this an odd or even function? It's even, so is this an S-type or a W-type? Number 3. So this is the information that I need to see. So for 3 through 8, if the answer is yes, I need 4 other pieces of information. Rational means that it has to be able to be written as a fraction. So think of it this way. For a polynomial, powers really have to be positive whole numbers. Okay, so if they're pi, which is irrational, or square root of 2, or the square root of 5, or something like that, we can't write square roots as fractions. So they are considered irrational.